Hello, everybody. I'm Arden, and today I'm going to introduce to you the Beobench Python package, a toolkit for unified access to building simulations for reinforcement learning. I haven't built this package all on my own. This was created together with my co-authors, Fyodor, Scott, and Keshav. Cool, let's get started. Before I dive into the actual package, I just want to give you a quick outline of the overall structure of the talk so you can stay oriented throughout. So I'll start off with a quick overview of the research area that Beobench is positioned in, and that's building energy optimization with reinforcement learning. People here generally will be very familiar with this area, so I'll keep this very short. And then in the second section after that, I will discuss some of the limitations of existing work that we have come across and kind of discuss the reasons for those. Then in the next section, the third section, we'll introduce the Beobench package and how it's an effort towards addressing some of these limitations. Obviously not going to solve everything, but it's our effort towards addressing some of these limitations. And then in the final section, I will demo a simple use case of Beobench, so you have a bit of a better idea of what Beobench actually looks like in practice and how this package works. Cool. With that, I will jump right in and introduce the research area, and that's building energy optimization using reinforcement learning methods. So building energy optimization or building control, as many of you will be very familiar with this topic, is all about this sort of goal of operating the different devices within a home in order to achieve some objective like minimizing energy cost or minimizing carbon footprint or related kind of goals. And yeah, this is often done tweaking different knobs, in terms of control, like setting the temperature of a certain zone within a building, or of sort of the heating and cooling system, or setting the charging the discharging charging rate of a home battery, stuff like that. Now, reinforcement learning is a control method that can be applied to these problems, and reinforcement learning control problems are formulated as an agent interacting with an environment. That's kind of illustrated here. And by interacting with the environment, the agent then receives rewards, and based on these rewards, it optimizes its control to maximize that reward. It's kind of the basic idea. And the sort of high-level benefit of reinforcement learning over other methods is that it requires a little bit less of a sort of perfect understanding of the system, of the problem. So compared to MPC, where you actually usually need a relatively good understanding of your system, with reinforcement learning, you can get away with a lot less. Okay, so much for the research area, for this sort of general idea of applying RL to building energy optimization. Let's go to the limitations. So there's actually been a lot of work in this space. A lot of different variations of methods have been applied to a lot of different buildings and building simulations. And yeah, overall, there's just been a wide array of work. But there were three limitations that I've kind of noticed throughout this work. Yeah, that are not, this doesn't apply to every single piece of work in the space, but it's quite common. So the first one is limited comparability. And that's all because of the way these experiments are designed. So usually often when a new method, a new RL method is being proposed to operate a building, it is evaluated on also a new building simulation. And so if you then want to compare this new method to another prior work method that is evaluated on a different building or different building simulation, that's just not really possible because these numbers they're not comparable. These are kind of apples and oranges. So that's where this sort of limited comparability comes from. But this is also a problem that has been widely recognized, and there's actually been a lot of effort, really cool stuff coming out of the last few years of frameworks that provide standardized environments so that people can evaluate their methods on the same buildings, on the same building simulations. And so some notable examples are here in this table. So you have Bobtest, Energym, RL Testbed, Synergym. Yeah, and so these are really cool, but there's still certain limitations that apply. And that is in particular because of the difficulty of creating building simulations is sort of work intensive part, and adding them into a reinforcement learning kind of framework. So most of these frameworks are still only have a handful of buildings. So it's a relatively small number of buildings that you can access through a single framework. The numbers that are here are as of February 2022, but I actually know that already Synergym and Bobtest both added new buildings. But the point here is not so much the exact numbers, but that they are, single digit, they're small, the amount of buildings that you can actually test on with a single framework. And so this kind of limited number of buildings per framework kind of motivates the idea of, let's try actually testing our method on multiple frameworks at the same time. So that's one of the reasons why you might want to do it. Another reason why you might want to use multiple frameworks at the same time is that, some work will use this framework to evaluate their method. Other work will use another one. So if you want to really put your new work into context with all of this other prior work, you want to really evaluate it on full kind of problem sets that are out there available. So again, you want to use as many frameworks as possible. And that kind of brings me to the third limitation, which is that it can be quite an involved installation process to get a framework up and running. That varies a bit depending on framework. Synergym is a notable example that is actually relatively easy to install. But there are sort of compatibility issues overall if you have different frameworks, and there is a certain overhead involved in using multiple frameworks. And so this motivates our goal, which is to make it easier to run comparable RL building control experiments on the same large set of buildings. And our proposed solution to this goal is Beobench, the Beobench package. So Beobench is a Python package that provides a unified interface to building simulations for reinforcement learning. This interface comes both in the form of a Python API and a command line interface. So depending on your workflow, you can choose which one fits you better. And the basic idea is to manage these frameworks and their dependencies in a Docker container, so the user doesn't really need to care about them. They're completely isolated and predetermined and sort of installed in different ways. And right now we already support simulations from Synergym, Bobtest, and Energym, which allows us to actually provide a large set of simulations. Okay, now we have a high-level view of how Beobench works. Let's go into a bit more detail. For me as a user, how exactly does this look like for me? So everything starts with the experiment configuration. That's really the most important part. The experiment configuration determines everything from the environment you're using, but also the agent that you use, and any other sort of parameters that you need to set. And there you can, that's really a lot of flexibility. There's also a lot of built-in agents, so you don't actually need to implement much to just get an experiment up and running. But if you want to, you can implement custom agents and also run experiments using them. And you can also add custom environments that you may want to run experiments on, custom buildings. So given all of this user input, you pass this into the Beobench API, which then checks, is there an experiment container image that already is kind of available and that would fit the problem, the sort of experiment, that configuration that it got. And if it doesn't exist, it will build it. Otherwise, it will just skip that build, and then it will run the experiment in a container. And then at the other end, the user gets the experiment results either in a local data directory or on these experiment tracking servers, like weights and biases. But the key thing here is the user doesn't really need to worry about the Docker part of things. You don't need to deal with Docker containers directly. This is all kind of handled in the background. Cool. With that, I want to give you an actual proper demo of what this looks like, so you have a bit of a better idea of how one might go about creating such a thing. Cool. Let me just add this here. I hope you can see this. So this is now an IDE, and here what we have is one of those experiment configurations. And here we have first the agent, which is a random action, and we take 10 time step, that's it. This is very much a baseline agent, but still good to have. Then we use an environment from the Synergym framework, and it's this E+ environment. And we add a wrapper. This allows us to log stuff to the weights and biases server. We also set some weights and biases parameters. The key here is hidden. That's in another configuration file. But obviously I didn't want to leave that. Cool. So we have this configuration file. Now we actually want to run the experiment. So we just say Beobench run, and we put the configuration, the demo.yaml, and we press enter. And there we go. We have our first Beobench experiment running. Yeah, so we already weights and biases is set up. Now Energy Plus is also running. It's the simulation framework behind things. And the test has actually already completed, and weights and biases uploaded all the data. So that's it. That's a very fast test. Obviously, things have been set up here. So usually the first experiment takes a bit longer than sort of consecutive ones, but it's kind of a demo, this usual user experience that you might have. Cool. With that, let's move back to the presentation and finish it all off. Thank you very much for your attention. If you want to learn more about Beobench, go to the GitHub. The address is shown here. It is pretty early stages of development, but feedback is very, very welcome. If you have any comments, we'll be very keen to hear. Things may change a little bit, but we'll love your feedback. If you want to contribute or you want to add support of your environment to Beobench, or you want us to add this support, reach out to me. I would be very curious, very keen to collaborate. Any questions, any comments are very, very welcome. Thank you very much for listening.